Let's build an AI agent from scratch. Not a chatbot that just answers questions, but an actual agent that can think, plan, and take actions to accomplish goals. By the end of this video, you'll have a working agent that can use tools, remember context, and solve multi-step problems. We'll use Python, and I'll explain every line of code so you understand exactly what's happening. Whether you want to build customer support bots, coding assistants, or research agents, this is where you start. Let's get our hands dirty and build something that actually works. First, let's set up our development environment. You'll need Python 3.9 or higher installed. Create a new project folder and set up a virtual environment. Run Python mvenv, then activate it. On Mac or Linux, use source venv/bin/activate. On Windows, use venv /scripts/activate. Now install the dependencies. We need the OpenAI package for the LLM, python.env for environment variables and requests for making API calls. Run pip install OpenAI python.env requests, create a .env file and add your OpenAI API key. You can also use Anthropic's Claude if you prefer, just swap the client library. Store your API keys securely, never commit it to version control. With the environment ready, let's start building. Before we write code, let's understand the architecture. Our agent has four main components. First, the brain, which is the large language model that does the thinking. It receives prompts, reasons about tasks, and decides what to do next. Second, tools, the functions the agent can call to interact with the world. These might include searching the web, reading files, running calculations, or calling APIs. Third, memory, which stores conversation history and important context. This lets the agent remember what it's done and refer back to earlier information. Fourth, the loop, the core execution cycle that runs until the task is complete. The agent thinks, chooses an action, executes it, observes the result, and repeats. This architecture is called REACT for reasoning and acting. It's simple but powerful enough to handle complex tasks. Let's connect to the LLM. Create a file called agent.py. Import the OpenAI client and load your API key from the environment. The key function is get_completion, which sends a prompt to the model and returns its response. We'll use GPT-4 or GPT-3.5-turbo. Set the temperature to 0.7 for balanced creativity and consistency. The messages parameter takes a list of conversation turns. Each message has a role, either system, user, or assistant, and content. The system message sets the agent's personality and rules. Something like, "You're a helpful AI agent. You can use tools to accomplish tasks, think step by step, and explain your reasoning." The user message is the actual request. Call client.chat.com. Pletions.create and extract the response content. That's your LLM connection. Simple but essential. Now let's define some tools. Tools are just Python functions that the agent can call. Start with a simple calculator tool. It takes a mathematical expression as a string and returns the result. Use Python's eval function, but wrap it in a try except for safety. Next, create a get_current_time tool that returns the current date and time. Then a search_web tool that takes a query and returns relevant information. For now, you can mock this or use a real search API. Each tool needs a description that the LLM can understand. Create a tools dictionary that maps tool names to their functions and descriptions. For example, calculator evaluates mathematical expressions, get_time returns current date and time, searches the web for information. The descriptions help the LLM choose the right tool, be specific about what each tool does and what parameters it. The agent loop is where everything comes together. Create a function called run_agent that takes a user query. Initialize an empty list for conversation history. Add the system prompt that explains the agent's capabilities and available tools. Include instructions for how to request tool calls. A common format is to use a tool, respond with tool, tool_name, args, arguments. Start the loop. Add the user query to history and call the LLM. Parse the response to check if it's requesting a tool call. If it contains tool, extract the tool name and arguments. Execute the tool function and add the result to the conversation. If there's no tool call, the agent is done. Return the final response. Add a maximum iteration limit, say 10 turns, to prevent infinite loops. Print each step so you can see the agent's reasoning. This loop continues until the agent has enough information to answer or hits the iteration limit. Memory is crucial for complex tasks. There are two types. Short-term memory is the conversation history we're already using. It stores the current session's context, but it's limited by the model's context window, typically 4K to 128K tokens depending on the model. Long-term memory persists across sessions. For simple implementations, save important information to a JSON file. Create a memory.json file that stores key facts, completed tasks, and user preferences. Add functions to save and load memory. When the agent starts, load the memory file. Before calling the LLM, include relevant memories in the system prompt. After important actions, update the memory. For production agents, you'd use a vector database like Pinecone or Chroma to store and retrieve memories based on semantic similarity, but for learning, a simple JSON file works fine. The key insight is that memory transforms a stateless chatbot into an agent that learns and improves over time. Let's test our agent. Create a test file with sample queries. Start simple. What is 25 times 37? The agent should use the calculator tool and return 925. Try. What time is it? It should call the time tool. Then try a multi-step task. Search for the population of Tokyo and calculate what percentage it is of Japan's total population. Watch how the agent chains multiple tool calls together. Debug common issues. If the agent doesn't use tools, check your system prompt. Make sure it clearly explains when and how to use tools. If it gets stuck in loops, add better stopping conditions. If responses are inconsistent, lower the temperature. Add logging to see exactly what's happening at each step. Print the raw LLM response, the parsed tool calls, and the tool results. This visibility is essential for debugging. Run multiple tests and iterate on your prompts until the agent behaves reliably. You've built a working AI agent. It can reason, use tools, and solve multi-step problems, but this is just the beginning. To level up, add more tools like file reading, web browsing, or database access. Implement better error handling so the agent recovers gracefully from failures. Add a planning step where the agent outlines its approach before acting. Explore frameworks like LangChain, AutoGen, or Crew AI that provide pre-built components. Consider safety measures like input validation and output filtering. In the next video, we'll explore RAG, Retrieval Augmented Generation, which lets your agent access custom knowledge bases. For now, experiment with your agent. Add new tools, try different prompts, and see what it can do. The best way to learn is by building. Drop a comment if you build something cool. I'd love to see what you create. Subscribe for more practical AI tutorials, and I'll see you in the next one.